From the dawn of humanity, we have gazed up at the stars and dreamt of reaching them. This yearning to explore the cosmos is woven into our very being. We have walked on the moon, landed probes on distant planets, and peered into the hearts of galaxies far, far away. Yet our journey into space has only just begun. Imagine a future where traveling to space is as simple as stepping into an elevator. Picture a ribbon of shimmering steel stretching skywards, a celestial highway connecting Earth to the heavens. This is the promise of the space elevator, a concept that has captivated the imaginations of scientists, engineers, and dreamers for decades. If realized, it could usher in a new era of space exploration, making space accessible to all. Imagine stepping into a capsule, not unlike a spacious elevator car, right here on Earth. You press a button, and smoothly, silently, you begin to ascend. As you rise higher and higher, the familiar sights of your city shrink below, giving way to the breathtaking curvature of our planet. This is the captivating vision of the space elevator, a concept that has fired imaginations for decades. The concept of a space elevator, while seemingly fantastical, is rooted in basic physics. Imagine a cable tethered to a spot on Earth's equator, extending far beyond geosynchronous orbit. Due to Earth's rotation, the outward centrifugal force acting on the cable would counteract the downward pull of gravity. With the cable anchored to Earth and held taut by a counterweight, a climber could ascend and descend the cable using a system of rollers or magnetic levitation. Turning the vision of a space elevator into a tangible reality requires overcoming a series of monumental engineering challenges. The most crucial element is the cable itself, which needs to be exceptionally strong and lightweight. Advancements in nanotechnology, particularly in the development of carbon nanotubes and graphene, offer a glimmer of hope. These materials possess extraordinary strength and could potentially form the backbone of a space elevator cable. While the concept of a space elevator might seem like a distant dream, recent technological advancements reveal a tapestry of progress. Nanotechnology is yielding materials with unprecedented strength-to-weight ratios. Carbon nanotubes and graphene exhibit remarkable strength and could be key to building the space elevator. Robotics, too, plays a crucial role, with increasingly sophisticated robots capable of constructing such a massive structure in space. At the heart of the space elevator concept lies the challenge of finding or creating a material strong enough to withstand immense stresses. Carbon nanotubes hold immense promise, with tensile strength over 100 times greater than steel at a fraction of the weight. Graphene, another contender, boasts exceptional strength and electrical conductivity. These materials offer a tantalizing glimpse into the future of ultra-strong, lightweight materials. Equally crucial is finding a suitable location on Earth to anchor the celestial tether. The ideal anchor point must be located as close to the equator as possible, away from major shipping lanes and air traffic. Scientists propose a mobile offshore platform positioned in international waters near the equator. This platform could adjust its location to avoid storms and other hazards, serving as a hub for space elevator operations. Providing a reliable and sustainable energy source to power the climber's ascent and descent is another hurdle. Solar power is a promising avenue, with the climber equipped with high-efficiency solar panels. Scientists are also exploring beamed energy, where ground-based stations transmit focused beams of energy to the climber. Another possibility is using the cable itself as a giant conductor, transmitting electricity from Earth-based power plants directly to the climber. The concept of a space elevator sparks intense debate. Proponents envision a future where journeying to space becomes as commonplace as boarding an airplane. Skeptics caution against unbridled optimism, pointing to the project's scale, complexity, and costs. The debate centers around the trade-off between risk and reward, with the potential rewards being revolutionary for space exploration. The voices of optimism, champions of the space elevator. Among the passionate advocates for the space elevator, we find a diverse group of scientists, engineers, entrepreneurs, and space enthusiasts united by their unwavering belief in the transformative potential of this technology. Dr. Peter Diamandis, founder of the X Prize Foundation and a vocal proponent of space exploration, envisions the space elevator as a gateway to the solar system, a catalyst for unlocking vast resources and enabling humanity to become a multi-planetary species. He argues that the economic and societal benefits of a space elevator far outweigh the initial investment, comparing it to the transformative impact of the transcontinental railroad or the internet. Dr. Brad Edwards, a leading researcher in space elevator technology and author of the book Leaving Earth: Space Stations, Colonization, and the Future of Humanity, has dedicated his career to advancing the feasibility of this ambitious project. He emphasizes that while challenges remain, they are not insurmountable, and the steady progress in materials science, particularly in the development of carbon nanotubes, provides grounds for cautious optimism. Entrepreneurs like Elon Musk, founder of SpaceX, while not directly involved in space elevator research, share a similar vision of making space accessible to all. Musk's relentless pursuit of reusable rockets and his ambition to establish a human colony on Mars demonstrate a belief in pushing technological boundaries and challenging conventional thinking, a spirit that resonates with the space elevator concept. The skeptics speak, challenges and concerns. While the vision of a space elevator inspires awe and wonder, a healthy dose of skepticism is essential in assessing its feasibility. Critics, often from the engineering and aerospace communities, raise valid concerns about the immense technological, economic, and logistical hurdles associated with such a project. Dr. Louis Friedman, a renowned aerospace engineer and former executive director of the Planetary Society, acknowledges the allure of the space elevator concept, but cautions against underestimating the challenges. He points out that even if we could manufacture a cable strong enough, maintaining its integrity in the harsh environment of space, bombarded by micrometeoroids and exposed to extreme temperatures, would be a monumental task. Dr. Robert Park, a physicist and author known for his critical analysis of space exploration proposals, expresses skepticism about the economic viability of a space elevator. He argues that the costs associated with construction, maintenance, and operation would be astronomical, potentially exceeding the economic benefits for the foreseeable future. He also raises concerns about the safety and security of such a massive structure, particularly its vulnerability to terrorism or accidental damage. Even within NASA, the agency tasked with pushing the boundaries of space exploration, opinions on the space elevator are divided. While some researchers acknowledge its potential, others remain skeptical, citing the lack of near-term technological solutions and the need to prioritize more immediate and achievable goals. Weighing the possibilities and pitfalls. The path towards a space elevator is fraught with uncertainties. It's a delicate balancing act, weighing immense potential rewards against formidable challenges. Breakthroughs in materials science and robotics are crucial. Economic feasibility and international collaboration are key. Balancing ambition with pragmatism will determine the future of the space elevator. Material matters. The quest for unbreakable strength. The challenge is finding a material strong enough for a space elevator cable, stretching over 35,000 kilometers. It must withstand its own weight and Earth's centrifugal forces. Carbon nanotubes offer hope, being over 100 times stronger than steel. Imagine a cable thinner than a hair supporting a jumbo jet. Engineering extremes, standing tall against the forces of nature. Beyond the material challenge, constructing a space elevator presents a myriad of engineering obstacles. The structure must withstand not only the constant pull of gravity and centrifugal force, but also the dynamic forces of wind, weather, and even space debris. One of the most pressing concerns is the dynamic stability of the cable. Imagine a guitar string stretched taut. Pluck it, and it vibrates. Similarly, the space elevator cable, exposed to winds and the Coriolis effect from Earth's rotation, will experience oscillations and vibrations. These movements, if not carefully controlled, could lead to catastrophic resonance, causing the cable to sway wildly and potentially snap. To mitigate these risks, engineers are exploring various solutions. One approach involves incorporating active control systems into the cable itself, using sensors to detect vibrations and actuators to counteract them. Imagine tiny motors distributed along the cable, constantly adjusting its tension and shape to dampen oscillations and maintain stability. Another challenge lies in protecting the space elevator from space debris. Micrometeoroids and defunct satellites whiz around Earth at high speeds, posing a constant threat of collisions. Even a small impact could damage the cable, potentially severing this vital link to space. Shielding the entire cable is impractical, so engineers are investigating strategies for debris avoidance, such as using lasers to nudge debris out of the cable's path, or designing the cable with self-healing properties to repair minor damage. The price of reaching for the stars costs, and economic considerations. The sheer scale and complexity of a space elevator translate into a hefty price tag. Estimates for the cost of such an undertaking vary widely, ranging from tens of billions to trillions of dollars, depending on the specific design and materials used. Securing funding for such an ambitious and expensive project poses a significant challenge. Governments, with their focus on shorter-term goals and budget constraints, might be hesitant to shoulder the entire burden. Private investors, while potentially attracted by the long-term economic prospects of a space elevator, would require convincing business models and a reasonable return on investment. However, proponents argue that the initial investment in a space elevator would be offset by the long-term economic benefits. Once operational, the space elevator could dramatically reduce the cost of transporting payloads and people to space, potentially by a factor of 100 or more compared to traditional rockets. This would open up a plethora of new opportunities for space-based industries, from asteroid mining and solar power generation to space tourism and scientific research. Moreover, the development of technologies required for the space elevator, such as carbon nanotube production and space-based construction techniques, could have significant spin-offs in other sectors, leading to advancements in materials science, robotics, and energy transmission, ultimately benefiting society as a whole. A future intertwined: humanity and the space elevator. The space elevator stands as a powerful symbol of humanity's ambition and our relentless pursuit of the stars. It represents a bridge between the realm of science fiction and the tangible possibilities of our future, a testament to our innate desire to transcend boundaries and explore the unknown. Whether it materializes in the coming decades or remains a distant aspiration, the very concept of a space elevator has already left an indelible mark on our collective imagination. The journey towards a space elevator is not merely about overcoming technological hurdles, it's about pushing the boundaries of human ingenuity, fostering global collaboration, and inspiring generations to come. The challenges are undeniable: the quest for super-strong, yet lightweight materials, the intricate dance of engineering against the forces of nature, the astronomical costs and logistical complexities. Yet, history has taught us time and again that seemingly insurmountable obstacles can be overcome when driven by a shared vision and unwavering determination. The potential rewards of a space elevator extend far beyond easier access to space. It has the potential to revolutionize our relationship with the cosmos, opening up new frontiers for scientific discovery, resource utilization, and even human settlement beyond Earth. Imagine a future where space travel is no longer the exclusive domain of astronauts and billionaires, but a tangible possibility for everyday citizens, where scientific outposts dot the solar system, and where asteroid mining fuels our growing energy needs. Beyond the horizon, a new era of exploration. The space elevator would mark a profound turning point in human history, akin to the invention of the airplane or the launch of Sputnik. It would usher in a new era of exploration, where the stars are a tangible destination. The impact of a space elevator on our world would be multifaceted and far-reaching. The cost of launching payloads and people into space would plummet, making space-based industries economically viable. Scientific research would flourish, unlocking new secrets of the universe. The dream of establishing a permanent human presence in space could become a reality. Space-based habitats and colonies on other planets could offer humanity a safeguard against earthly catastrophes. However, the path to this future is not without its challenges. We must balance our aspirations with a clear-eyed assessment of the risks involved. International collaboration, ethical considerations and environmental stewardship must be paramount. The space elevator represents a bold vision for the future, a testament to human ingenuity and our thirst for exploration. Whether it graces our skies or remains a distant beacon, the pursuit of this dream will shape human history and inspire generations to reach for the stars.